to upload. Sorry about that. Okay, so in this new set, find the general solution of each differential equation and then check it. Any preference, or I will choose?
Number 18.
Let's look at 18. So in 18, we have dv over dt equals 1.33v. Excellent. Okay. Like we did before, what do you think I'm going to have to do first?
Multiply by dt.
Of course, of course. Always remember we have to separate the variables. So this is the first problem in which we will separate the variables. Okay, so first I have to take care of this. Good. So then I have dv equals 1.33 times v times dt. But see, dv is here and I also have v here. I can't do that. All v's and dv's have to be on one side. All t's and dt's have to be on this side. What would you think of doing? What would you recommend? What would you say? Do this, and I'll do it.
Would you subtract 1.33v?
There is no addition and subtraction here. It's 1.33 v dt. So they're all multiplied.
Divide.
Yes, awesome. We divide both sides by v alone. So then I have dv over v equals 1.33 dt. Variables are separated. This side has only v, this side has only t. The number is not important. Okay, so now at this point we will integrate both sides, and we put only one c, only on this side. We discussed that why. Okay, my page 10. Good. The left-hand side. I need to integrate this. What do I get? I covered that. I don't want you to be distracted by that side. That side is not important right now. I want to integrate dv over v. What do I get?
It's just v.
Careful. You told me a few minutes ago. The integral from 1 over x is natural log of the absolute value of x. So what do I have on this side?
Would it be dv times natural log v? Or the absolute value of v?
Right? It's natural log. So maybe the v is confusing. So let's stop for a moment and look here. If I have the integral from dx over x, how do I integrate this? What do I write?
You do the natural log times the absolute value of x.
Natural log of the absolute value of x plus a constant c. So now this may be confusing because I have v and v, but it's the same thing, x and x. So we get natural log of the absolute value of x plus a constant c, but we don't write a constant on this side. We're going to write on the other. Is everyone in the clear how I got from here, here?
Yes.
Okay. So please stop me if it's not clear, because from this point on, this will play a big role in the differential equations. So the integral from dx over x is natural log of the absolute value of x. The integral from dv over v is natural log of the absolute value of v. We agree, yes? The right-hand side now. So don't get distracted by the left-hand side. What do I get on the right?
Do you have to add a constant to the other side?
So remember what we talked a few minutes ago? I should add a constant on both sides.
Oh, okay.
But if I do, at some point in time, I will move this constant to this side and have a combined constant. So there is no need to add the constant on both sides. We only add it to one side.
Thank you.
Thank you. It's okay. We need to, this is, every practice is like that. We need to repeat things. We need to talk about things more than once. Nothing to be ashamed of. Okay, so what do I do here? Don't look on the left-hand side. Just tell me how you integrate this. Anyone?
Would it just be 1.33 T?
Very good. Awesome. Plus a constancy. Awesome. That's it. Okay. Remember, we are solving for V. Must solve for V. Okay. Good. So now this is algebra. This is no longer calculus at this point. Okay.
I had a quick question.
Yes.
Why is it just T? I can't remember.
Okay, so let's differentiate. When I differentiate 1.33t, I get 1.33.
Mhm.
When I
Oh,
differentiate
okay.
the constant, I get 0.
Okay,
Better?
thank you.
So if I have a t in here, then I have to write t squared over 2. But I don't have t. I have 1 if you want to write 1. So which function prime is 1? T.
Oh, that makes sense. Thank you.
Better?
Yeah.
Good. So now, from this point on, there is no calculus. It's just algebra. We have to solve for V. Good. So again, I don't want you to get confused. And tell me, how do I solve an equation like this? Natural log of something equals something. So don't even look at this. See, these are my props. So tell me, how will you solve something like this? Natural log of whatever equals something. How do I solve this?
I don't know if this is the answer, but isn't the opposite of the natural log E?
I think you use log, right?
Careful, careful. Can anyone tell us the base? I don't see a base here. What is the base here?
10.
Careful.
E.
LOG has base 10. Oh, where's my calculator? Oh, it's plugged, it's charged now. See here? LOG goes with 10, and LN goes with e to the x. So the base of LOG is 10, and the base of LN is?
E.
That's it. So we don't write it, but we know it's there. How do I solve this? Is e raised to this power, counterclockwise, e raised to this power equals this number. E raised to the triangle equals the rectangle. This is what I have to use over there to solve for V. Base raised to this number equals this number. I hope I didn't upset anyone. Okay, so since the base is e, e raised to all this equals the absolute value of V. So the absolute value of V equals e raised to power 1.33t plus a constant c. Only after you say, I understand this step, we can continue.
We understand.
This is a crucial step here. One more time. E raised to all this equals the absolute value of V. Now, on this side, so again, don't look at this side. I want you to get confused. I'm focusing on this side for a moment. We know that E to a power plus another power can be written as e to the first power multiplied by e to the other power. How do I know? Because it's a raised to m times a raised to n equals a raised to m plus n, and I can go back. So if I have a to a plus b, this is, I'm sorry, e to a plus b, I have e to a times e to b. Okay? This is another crucial step. So I will separate that into e to 1.33t times e to c. Again, this is another crucial step in solving. So I continue. The absolute value of v is e to 1.33t times e to c. When you say I understand this step, using this property, the product rule, when both bases are the same, I can add the exponents, but I can also go back. If I have a base raised to a sum, it comes from this. The product of the two exponential notations with the same base, and I just add the exponents. When you say this is clear, then I can continue. Do I get a yes or a maybe?
It's clear.
Okay, so now remember the absolute value. The absolute value has plus or minus. I'll put this in front because it's a constant. E to c times e to 1.33t. And yes, this whole thing can be replaced by one constant. And normally we like to denote this constant by v0 because it's v, like an initial value. So then v equals v0 e to 1.33t. And now we have the function. We solved the differential equation. And look at how many steps we needed to go through and explain. First, we multiply by dt. Then we separate it. I can't have v and t on one side or the other. So I had to divide by v. Then I integrate it. So this is clearly natural log of the absolute value of v, and this is 1.33t plus a constant c. Then we had to dig deep in our algebra skills. E raised to this is the absolute value of v. Then again, we had to talk about the product rule that adds the exponents. Then we did that. We applied this product rule reversed, if you want, in the reversed way. And then we said, okay, this is all a constant. Who cares? Let's denote it by something. And we did. And this is the answer. Now in part B, they're asking us, now show that this is a solution to the differential equation. So I have to go back. First of all, this is my page 11. I have to copy this. So dv over dt equals 1.33v. Fine. So let's check it out. So first of all, the right-hand side is very clear, right? So what do I have? 1.33 times this. So the right-hand side equals 1.33 v0 e to 1.33 t. I'm done with the right-hand side. Now I have to work on the left-hand side and show that it's this. If I cannot show that it's this, then that is wrong, right? So I'm here. So I want to find dv first. Okay, how do I find dv? I know how. This is the function prime times dt. That's what dv is. So f prime of t times dt. That's f prime of t. So dv will be v0 times e to 1.33t times 1.33. So I'm still working on the left-hand side. I want dv over dt now. So the left-hand side is dv, which is all this. Oh, sorry. So dv is the function times dt, of course. So now the left-hand side is v0 times 1.33 times e to 1.33t times dt divided by dt. And look what I got as the left-hand side, and look what I got as the right-hand side. 1.33 v0 e to 1.33t. So I'll say yes. Our solution is correct. V equals v0 e to 1.33t is the solution. It may not be the only one, but it's the solution. That's what I said. This part is really the only intense, I think, because it just takes us all over the place. Integration, differentiation, algebra, solving equations, etc., etc. Okay, so let's continue. I know I'm down to 5 minutes. Okay, so let's choose a problem from 23 through 34. Find the particular and then check. Okay, so this set. And then we'll continue on Thursday with all the rest and word problems. So anything we want to choose from 23 through 34. And then we'll stop. Okay, I'll choose 23. In 23, we have y prime equals x squared plus 2x minus 3. And the point is 0, 4. When x is 0, y is 4. So they're asking us to find, determine the solution, because we have an initial condition, the solution. It's not going to be a family of functions, but it's going to be a unique solution. And then check it. Okay, fine. So remember, dy over dx equals x squared plus 2x minus 3. We multiply by dx. We have dy equals x squared plus 2x minus 3 dx. I integrate both sides. X to the third over 3 plus 2x squared over 2 minus 3x plus a constant c. We've done this similar situations, very simple situations. Now I have to plug in 0, 0, 0, 4. So then c equals 4. So very simple. This is when we talked about basically antiderivatives, really. Okay, so then y equals x to the third over 3 plus x squared minus 3x and plus 4. So they're asking us now to check. There is nothing to check. That y prime equals x squared plus 2x minus 3. Of course, 3x squared, 2x minus 3, and 0. Okay, I think we have time for another one. What if we do 27? And I promise I'll stop after that. In 27, I see, of course, they're just trying to throw all sorts of variables and letters towards, or trying to confuse us. Okay, so we have b of 0 is 500, but we know what that means. That means 0, 500, that's the point. Okay. We had a very similar example before with the v, exactly the same. I have b to come here, and I have dt to go over there. So db over b equals 0.03 dt. We know the rule now, so this is natural log of the absolute value of b equals 0.03 t plus a constant c. We've done this a minute ago, 5 minutes ago. I plug in natural log Oh, better I just, let's solve this. So we know that the absolute value of b equals e to 0.03t times e to c. We've done this step, just with different letters. I had v here instead of b, same thing. And now I plug in the point. So when t is 0, this is 1. So then e to c equals 500. So e to c equals 500. I should write that b equals plus or minus 500 e to 0.03t. Why I will not write plus or minus? It's legitimate, but it says when t is 0, I get 500, but I get plus or minus. So which means only plus. So b equals 500 e to 0.03t. And we have to check.